Today we'll be having another case-based problem, this time from application of trigonometry chapter, and the problem goes like this. One evening, Kaushik was in a park. Children were playing cricket. Birds were singing on a nearby tree of height 80 meters. He observed a bird on the tree at an angle of elevation of 45 degree. When a sixer was hit, a ball flew through the tree, frightening the bird to fly away. In 2 seconds, he observed the bird flying at the same height at an angle of elevation of 30 degree, and the ball flying towards him at the same height at an angle of elevation of 60 degree. Just to get a proper idea of the situation, at this point C is the boy. He sees the on the top of the tree, the bird is here. He hits the ball towards the tree. The bird flies in this direction towards the point D and remains at the same height, and when he observes the ball is falling towards him and it is an angle of elevation of 60 degree and also at the same height. So the bird before, after, and the ball right now all are at a height of 80 meters. Now going to the first problem. At what distance from the foot of the tree was he observing the bird sitting on the tree? Now, according to this, we want to calculate the distance BC. Now, the side BC belongs to the triangle ABC, and we know the side AB, which is 80 meters, and also the angle of elevation here, which was given to us as 45 degree. So now using the right trigonometric ratio, we can calculate the distance BC. So in triangle ABC, angle B is given as 90 degree. Now for our angle 45 degree, AB is the opposite side and BC is the adjacent side. So the appropriate function is tan 45 degree, which will be opposite by adjacent, so AB by BC. 1 is equal to, which is the value of tan 45, AB is given to us as 80, BC is what we are trying to calculate. So here we get that BC is equal to 80 with the right units, that is meters. And this solves our first part. Now going to the second part. How far did the bird fly in the mentioned time? Now the bird flew from point A to point D. Now AD value is equal to the value of BE. Now BE does not separately belong to any one triangle, but we can calculate the full side EC and then subtract the BC value, which will end up giving us the value of BE. So let us calculate EC first. Now in triangle CED, angle E is equal to 90 degree. Tan 30 equal to opposite, which is DE divided by CE. Tan 30 is equal to 1 by root 3, which is equal to DE, which is 80 divided by C is what we want to calculate. So CE is equal to 80 into root 3 meters. Now we can go to calculate what we exactly require. Therefore, distance the bird flew, that will be equal to, I told that is equal to AD, which is equal to BE, and BE is equal to EC minus BC. EC we calculated right now, which is 80 root 3 minus 80. BC is calculated in the first part. Always take common out for our final answer, root 3 minus 1 meters, and this is what we wanted. Now going to the third part of the sum. It is asked that after hitting the tree, How far did the ball travel in the sky when Kaushik saw the ball? Now, the ball hit the tree at point A and flew back to point F. So we want to calculate AF. Just like the previous part, we cannot calculate AF, we calculate BG. And BG is not a part of a separate triangle, but we know the full value BC calculated in the first part. And here we will calculate the value CG, which belongs to triangle CGF, and from there we can subtract it from BC. So let's see how it goes. In triangle CGF, angle G is equal to 90 degree. Now tan 60 is equal to opposite, which is FG, divided by CG. Tan 60 value is √3. FG is not exactly given to us directly as 80 meters, but it is mentioned in the sum that the ball was at the same height as the bird. So that is 80 divided by CG is what we want to calculate. CG is equal to 80 divided by √3 meters. Now going to the part where we calculate what is asked for us. Therefore, distance the ball traveled that will be equal to, we said AF. AF is equal to BG. BG is nothing but BC minus CG. BC was calculated as 80 meters in the first part, and this is 80 divided by √3. We take the LCM. 80 √3 minus 80 divided by √3. We can take common out in the numerator. 80 √3 minus 1 divided by √3. Finally, rationalize our answer by multiplying by √3 and dividing by √3. 80 √3 into √3 minus 1 divided by 3 meters, and this is the final answer. Now finally, last one sum left. What is the speed of the bird in meters per minute? This is the part we need to be careful. Meters per minute. It had flown only a distance of 20 into √3 plus 1. So we know that speed is equal to distance divided by time. Now distance is given to us as 20 into √3 plus 1. Time, it was given to us in the sum here that it has flown in 2 seconds. So time will be 2 here. 2 cancels with 20. 10 into √3 plus 1 meters per second right now. Now to convert this into meters per minute, we have to multiply our answer with 60, and this gives us meters per minute. 60 into 10, 600 into √3 plus 1 meters per minute, and this is the final answer. And here we complete our sum. Hope you had good clarity of the sum. Share it with your friends, like the video, and subscribe to the channel. See you in the next one.